Okay, so the last part of this section is just kind of explaining the difference between causation and correlation because it feels like it's causation, especially when it's logical. Like, of course, the deeper you go, the rocker's going to be dense and you're going to drill longer, duh, you know. Shoe size and height, of course, as you grow, your shoe size is going to get bigger. Like, it's duh, you know. But then I could talk about butter and divorces, right? Oh yeah, the more you butter, the more you're gonna get divorced, right? Duh, you know. Then it's like, whoa, 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 you're going too far there, Darlene. So that's why we talk about causation and being careful with causation because it's not always it's not a causation. And if you wanted to do a causation, you would need an extreme amount of experimental studies and a lot of money and time to do it. So we're just going to have a couple examples here, just kind of the difference between a causation and correlation and just being aware of how we say it and how we don't want to misinterpret a relationship and a causation. So, a correlation is not causation is a logical fallacy. And just because two variables are correlated doesn't mean that one causes the other to change, right? So let's look at this example. It's obtained from the Statistical Abstract of the US, and the correlation between the percentage of female population with a bachelor's degree and then the percentage of births to unmarried mothers is 0.940. Does this mean that a higher percentage of females with a bachelor's degree causes the higher percentage of births to unmarried mothers? Right? So like I said, it's like butter and divorces. So females with bachelors are causing births to unmarried mothers. Like how am I causing people to have babies without being married? Because I have a bachelor's degree? Like that doesn't make sense, right? But look at the correlation coefficient. That's almost 1. Like that is almost an exact positive linear correlation. So we can see just by the context of the scenario, it's not really practical to say that because you have a bachelor's as a female, you're causing other women to have babies that aren't married. And it's just not true, right? So let's write something down. So just because R is 0.940, almost exactly a positive linear correlation. It doesn't mean, or it doesn't imply that the percentage of, or I should say that the percentage of females, or I should say that females with BS or BAs are causing females to have births unmarried or unmarried births or something like that. Married births unmarried. I'm sure you can word it better. So just because R is 0.940, almost exactly a positive linear correlation, it doesn't imply that females with bachelor's degrees are causing females to have births unmarried. Right? I would agree. But is to take in consideration the lurking variables, right? Like, okay, so maybe we're not looking at exactly one causes the other, but maybe we're looking at it through like a lurking variable because it's related to both. So almost like the drilling rock, right? We said the density of rock. The density of rock will determine how long it takes to get to through that rock because it's harder, right? Like the jawbreaker. And also, it also has to do with the starting drill depth because the density of the rock of where it starts could also be dense. So a lurking variable will affect either or the explanatory response. So let's just say, for example, I took ice cream sales. Ice cream sales and crime rates have a very high correlation. Does this mean local government should shut down all ice cream shops? Right? So we would just say, well, no, we love ice cream, but they're saying that ice cream shops and crime rates have some sort of correlation, right? But does that mean because ice cream shops, we should close the ice cream shops and it'll stop crime? No. Like, what are some other things that could have that relationship? Um, I don't get, I'll give you a moment, but like the first thing that comes to mind is probably the location of the ice cream shops, right? So what are some things? Um, Ice cream location of ice cream shops. Um, if it depends, like if they're an ice cream truck, mostly have cash, so they could be very well like a target, right? Um, okay, so does this mean that local government should shut down all ice cream shops? So we'll say no, because if there is a correlation, there could be other factors to take in consideration. Like location and type of currency. So just so you know, just make sure that you understand that correlation doesn't mean causation and that it's easy to go that route sometimes, but it's just not the way it is. Just means that there's a strong relationship between the two and that we always have to take into account lurking variables as part of being the unexplained part of the explanatory power. Okay.